Welcome to this comprehensive overview of artificial intelligence tools for inventors as of 2025. Today we're going to explore how AI is revolutionizing the innovation process. The landscape of invention has been fundamentally transformed by artificial intelligence. Let me ask you a question. What makes AI tools particularly valuable for inventors? The answer lies in three key capabilities. First, I can rapidly analyze vast amounts of existing patents and research. Second, it can generate and optimize designs at unprecedented speeds. Third, it can predict market viability and technical feasibility. These capabilities compress what used to take years into weeks or even days. Now let's dive into the specific categories of AI tools available to inventors. The first category is patent analysis and prior art search tools. These are absolutely critical for any inventor. Modern AI patent search tools use natural language processing and semantic analysis. You can describe your invention in plain language, and the AI will identify similar existing patents and highlight what's truly novel about your approach. Tools like PatentPal, Specifio, and IP Rally use transformer models similar to GPT. They can analyze millions of patents in seconds and provide semantic similarity scores. This is revolutionary. What used to require patent attorneys spending hundreds of hours can now be done in minutes with higher accuracy. The second category is generative design and computer-aided design tools. Here's a question. How does AI-driven generative design differ from traditional CAD? Traditional CAD requires you to manually specify every dimension and feature. AI generative design works from constraints and objectives. You specify what you need, like weight under 2 kilograms, strength above 500 newtons, and cost under $50. The AI generates thousands of design candidates and evolves them using algorithms inspired by natural selection. Leading tools include Autodesk Fusion 360 with generative design, Intopology for complex lattice structures, and SolidWorks with AI-enhanced features. These systems use topology optimization, which redistributes material only where it's structurally needed, and evolutionary algorithms that iterate through generations of designs. Category 3 is materials discovery and selection. This is where AI is making some of its most impressive contributions. Machine learning models trained on vast materials databases can predict properties like tensile strength, thermal conductivity, and chemical stability without requiring physical prototypes. For example, I can predict that an aluminum copper titanium alloy with 60% aluminum, 25% copper, and 15% titanium will have specific desired properties before you ever mix the materials. Key platforms include Citrine Informatics for industrial materials, the Materials Project database, and AFLOW for crystalline materials prediction. Here's an important question. What's the accuracy of these AI predictions? State-of-the-art models achieve 90 to 95% accuracy for many properties, which is remarkable but not perfect. This means you still need experimental validation, but you've dramatically reduced the number of candidates you need to test physically, from thousands down to perhaps 10 or 20. Category 4 is market research and trend analysis. This helps inventors understand if there's actually demand for their innovation. AI tools can analyze millions of consumer reviews, social media conversations, patent filings, and market reports to identify emerging needs and opportunities. The AI aggregates data from multiple sources and provides quantitative scores for market opportunity, competitive intensity, and growth potential. Leading tools include CB Insights for startup and technology trends, Gartner's AI-powered market research platform, and Crayon for competitive intelligence. These tools excel at identifying whitespace opportunities where customer needs exist, but current solutions are inadequate, and spotting trends months before they become mainstream. Category 5 is prototyping and simulation. Let me pose another question. Why is AI-powered simulation crucial for modern inventors? The answer is that physical prototyping is expensive and time-consuming. AI-powered simulation lets you test thousands of design variations virtually before building anything physical. This dramatically reduces development costs and time to market. You can simulate mechanical stress, fluid dynamics, thermal behavior, and even user interactions. Compare the cost difference. A physical prototype might cost $5,000 and take 2 weeks. An AI simulation costs perhaps $50 in compute time and takes 2 hours. Key tools include ANSYS Discovery with real-time physics simulation, Siemens SimCenter for multiphysics, and COMSOL for coupled phenomena. Traditional finite element analysis could take hours for a single simulation. AI surrogate models trained on previous simulations can predict results in seconds with 90% accuracy. Category 6 is natural language interfaces for technical work. This is perhaps the most accessible category for inventors. Modern AI tools let you describe your invention in plain conversational language rather than needing to learn complex technical syntax or programming languages. You can say something like, "I need a bracket that holds 10 kilograms at 45 degrees," and the AI will generate appropriate CAD geometry, suggest materials, and even estimate manufacturing costs. Tools like ChatGPT can help with patent writing and technical documentation, while Claude excels at analyzing complex technical problems and suggesting solutions. This democratizes invention by giving non-experts access to capabilities that previously required years of specialized training. Category 7 is intellectual property strategy tools. These help you not just file patents, but develop comprehensive IP strategies. I can map entire competitive patent landscapes, showing you where competitors are filing patents, identifying gaps in coverage, and suggesting strategic filing opportunities. The AI visualizes where different companies have patent coverage and identifies white space where you could file to establish a strong position. Leading platforms include PatSnap for patent analytics, Questa Orbit for comprehensive IP research, and Acclaim IP for strategic patent analysis. Here is another key question. How does AI actually improve patent quality? AI analyzes thousands of successful and rejected patents to identify claim language that is broad enough to be valuable, but specific enough to avoid rejection. It can suggest alternative phrasings and identify potential obviousness issues before filing. Category 8 is AI-powered collaboration and project management for invention teams. Modern inventions often involve distributed teams. AI tools can coordinate mechanical engineers, electrical engineers, materials scientists, and business strategists working across time zones. These systems analyze team member skills and experience to suggest optimal task assignments, predict bottlenecks, and automatically schedule meetings when key decisions need to be made. The AI acts as an intelligent coordinator, understanding dependencies between tasks, and ensuring information flows to the right people at the right time. Tools like Monday.com with AI features, Asana Intelligence, and Notion AI integrate project management with intelligent automation and suggestions. Category 9 is manufacturing optimization and supply chain management. This helps you actually produce your invention at scale. AI systems can optimize manufacturing parameters like temperature, pressure, and timing to maximize quality while minimizing cost and energy consumption. They also monitor global supply chains, predict potential disruptions months in advance, and automatically suggest alternative suppliers or materials when problems arise. The AI continuously monitors the entire supply chain from raw materials through manufacturing to final product, optimizing every step. Enterprise tools include Siemens Opcenter for production optimization, SAP with embedded AI, and Oracle's AI-powered supply chain management. An important question: what kind of cost savings can AI actually deliver in manufacturing? Studies show that AI optimization typically delivers 15 to 30% reduction in production costs through better parameter tuning, reduced waste, and improved yield rates. Some manufacturers report even higher savings. The final category is sustainability and environmental impact assessment. This is increasingly critical for modern inventors. AI tools can calculate the complete carbon footprint of your invention from raw material extraction through manufacturing, use, and eventual disposal or recycling. For example, the AI might calculate that your product generates 150 kilograms of carbon dioxide equivalent across its life cycle and give it a sustainability score of 7.2 out of 10. More importantly, the AI suggests specific design modifications that could improve sustainability, like alternative materials with lower embodied carbon or design changes that improve recyclability. Key tools include Sphera for lifecycle assessment, SEMA Pro for environmental impact modeling, and Gabby for comprehensive sustainability analysis. Now let's discuss how these 10 categories integrate into a complete inventor's workflow. Modern inventors typically use 5 to 7 different AI tools simultaneously, each specialized for different aspects of the development process. The workflow starts with idea generation, flows through patent search and market research, then to design and simulation, and finally to IP strategy and manufacturing planning. Many tools now offer APIs that allow automatic data sharing. Your CAD model can flow directly into simulation software, and simulation results can feed into manufacturing optimization. Let's be honest about the challenges and limitations. AI is powerful but not perfect. First, AI is only as good as its training data. If the data is biased or incomplete, the AI suggestions will be flawed. Garbage in, garbage out remains true. Second, many AI systems are black boxes. They provide recommendations but can't always explain why. This is problematic when you need to understand the reasoning behind a critical design decision. Third, enterprise-grade AI tools can be expensive. Initial costs for comprehensive systems can range from $50,000 to several $100,000, though costs are dropping. Fourth, there's a learning curve. Inventors need to understand both their domain and how to effectively prompt and guide AI tools to get useful results. This raises an important question. Should inventors trust AI recommendations completely? Absolutely not. AI should augment human judgment, not replace it. Always validate AI suggestions with domain expertise, physical testing, and critical thinking. AI can miss edge cases and make assumptions that don't apply to your specific situation. Let me share some best practices for inventors using AI tools effectively. First, start with clear objectives. The more specific you are about what you're trying to achieve in your constraints, the better AI can help. Vague inputs produce vague outputs. Second, always validate AI outputs. Use your expertise to sanity check recommendations. Does this material choice make sense given the operating conditions? Is this market projection realistic? Third, iterate. Don't expect perfect results on the first try. Use AI outputs as starting points, refine them, feed the improvements back into the system, and iterate until you converge on optimal solutions. Fourth, use multiple tools for cross-validation. If 2 independent AI systems suggest similar solutions, you can have higher confidence. If they disagree, that's a signal to investigate further. Fifth, document everything. Keep records of what AI tools you used, what inputs you provided, and what outputs you received. This documentation can be valuable for patent applications and if questions arise later. Let's look ahead. What's coming next in AI tools for inventors? First, we're seeing multimodal AI that combines computer vision, natural language, and simulation. You'll be able to sketch an idea on paper, take a photo, describe verbally what you want, and have the AI generate complete technical specifications. Second, autonomous agents are emerging that can manage entire invention projects. You give high-level goals, and the AI autonomously coordinates patent searches, designs, simulations, and even initial supplier negotiations. Third, quantum classical hybrid systems are beginning to appear. For certain optimization problems, quantum computers can explore solution spaces exponentially faster than classical systems. Fourth, costs continue to drop. Tools that cost hundreds of thousands 5 years ago now have cloud versions accessible for hundreds per month. This democratization means individual inventors can access capabilities previously limited to large corporations. Let's consider the economic impact. How is AI changing the economics of invention? Traditionally, bringing a complex invention from concept to market might take 5 years and require $2 million in investment. With AI tools, that same process might take 18 months and $400,000. That's a 70% reduction in time and 80% reduction in cost. This dramatic reduction in barriers means more inventors can bring ideas to market, increasing innovation velocity across the economy. We need to address ethical considerations. AI in invention raises important questions. First, Ownership. If an AI generates a novel design, who owns it? The person who prompted the AI? The company that made the AI? Current law says, A, I can't be an inventor, but the boundaries are unclear. Second, novelty. If an AI suggests a design by interpolating between existing patents, is it truly novel? Patent offices are still developing guidelines for AI-assisted inventions. Third, bias. If AI training data predominantly includes inventions from certain demographics or regions, the AI might perpetuate historical biases in what problems get solved and how. Fourth, environmental cost. Training large AI models requires enormous energy. Is the environmental cost of the AI tools offset by the efficiency improvements they enable? This requires careful lifecycle analysis. Let me conclude with practical recommendations for inventors, starting with AI tools today. Start with accessible tools. Use ChatGPT or Claude for brainstorming and documentation. Try free tiers of CAD software with AI features. Build familiarity before investing in expensive enterprise tools. Focus on what you know. Use AI to expand into areas outside your expertise, but ground it with deep knowledge in your core domain. AI is best at breadth, humans at depth. Build a network. Connect with other inventors using AI tools. Share experiences about what works and what doesn't. The field is evolving rapidly, and community knowledge is invaluable. Stay current. AI capabilities improve every month. Subscribe to newsletters, follow key researchers, and periodically reassess whether new tools could enhance your workflow. Keep creativity central. AI is a tool for executing and optimizing ideas, but breakthrough innovations still require human creativity, intuition, and the ability to see problems from novel angles. Let me summarize what we've covered about AI tools for inventors in 2025. AI tools now span every phase of the invention lifecycle, from initial ideation through patent strategy, design, simulation, manufacturing, and sustainability assessment. These tools can reduce development time by 60 to 70% and costs by 70 to 80%, making invention accessible to more people. However, human judgment remains essential. AI augments human capabilities. It doesn't replace human creativity, domain expertise, and ethical reasoning. Looking ahead, we'll see even more powerful multimodal systems, autonomous agents, and quantum-enhanced optimization, further accelerating the pace of innovation. Here's my final thought. The most profound impact of AI on invention isn't just speed or cost reduction. It's democratization. AI tools enable individual inventors and small teams to access capabilities that were previously only available to large corporations with massive R&D budgets. This democratization could unleash a wave of innovation from diverse perspectives and regions worldwide, solving problems that large institutions have overlooked. We are at the beginning of a new era, the age of the AI-augmented inventor. Those who learn to effectively collaborate with AI while maintaining human creativity and judgment will be the ones shaping the future.